Okay, question 19. A relation is defined on the set of real numbers such that x relates y and y relates x implies x equals y. So this relation is said to be what type of relation? So these are the conditions for the different type of relations. So if x relates to itself, x relates to x, we say it's reflexive. So reflexive, we have just a single variable, x relates to itself. Now, when we have two variables, that is x and y, we either have a condition of symmetric or anti-symmetric. So in the first one, if x relates to y and y implies y relates to x, then we say it's symmetric. But if the second condition of if x relates to y and y relates to x means x is equal to y, when this condition adds, we talk about anti-symmetry. If there are three variables, x relates to y and y relates to z implies x relates to z, we talk about transitivity. So which of these cases do we find in our question here?
It's just
okay. We thank the head of state for giving us good connection in Cameroon.
Cameroon.
Of course. Maybe, sometimes. It depends on the time of the year. All right, so which of these conditions gives us, do we have here?
Anti-symmetric.
So it's anti-symmetric. Vivi, do you want me to do something for you?
Excuse me?
You have sent me, I don't know what is a message or something. Do you want me to do something?
I can't get you.
Yes, I've seen something. You are requesting for access to something. I don't know.
You have to ask more.
You want access to record or access to anything? That's what I'm asking because my site is telling me that you've requested access to something. I don't know what is it.
No, sir. I'm sure it's a mistake.
All right, thank you.
Just for something.
Okay, so we have an anti-symmetric condition here. All right, question 20. A function y satisfies the differential equation y dy dx equals x. If x equals 1, when y is equal to 1 when x equals 0. So when this happens, what equation do we have? How do we solve this differential equation? Which method can we apply to solve this? You have y dy dx equals x. We can solve this one by separating variables. So I'll make sure that everything that is x should appear on one side and everything that is y should appear on another side. So this will give us, cross multiplying by dx, will have y dy to be equal to x dx. At this point, we can now take our integral on both sides. And the integral of y dy will be half y squared. Integral of x dx will be half x squared plus a constant of integration.
And I feel that the goal is...
Yes, please. Right now, at this step, when x is equal to 0, y is equal to 1, so we can solve for k. So if you substitute these values, you are going to have a half is equal to 0 plus k, so our k is equal to a half. From here, if you multiply all through by 2, we are going to have y squared to be equal to x squared plus 1. So which of these answers do we have?
A.
Okay, A. Any questions here?
No.
No, sir.
Right, so we can move to question 21. right. Good. So you can contact us here. If you want to contact me by email directly, you can either go to gmail.com. This Gmail. I'll hardly go to use Yahoo. So directly is gmail.com. Okay.
Yes,
Yes.
sir.
And on WhatsApp, you can contact this number which is here. But if you have to get to us to respond as fast as possible, then you use the second number, which is not starting with +237. Funny and strange. We are in the Badlands. Okay, so given that n combination 2 is equal to n combination 3, then what is the value of n? So n combination 2 is equal to
N,
what? Yes,
N factorial.
yes, please.
N
On,
N minus R.
on 2 factorial
yes,
into N minus 2.
perfect. So we have n factorial on 2 factorial into n minus 2 factorial should be equal to, so with n combination 3, the same thing, n factorial on 3 factorial into n minus 3 factorial. We can cross multiply and cancel out. You will have 2 into n minus 2 is equal to, now, n minus 3 factorial is the same as n minus 3 times n minus 2 factorial. Something has disappeared here now. Has something disappeared? All right, anyway, let's just continue. So here we have 2 factorial is 2, and then n minus 3. I think I've left out something here. Let me write this freehand. Let me do it freehand. So when we cross multiply, all of these things will cancel out. We'll just be left with 2 factorial into n minus 2 factorial, n minus 2 factorial should be equal to, in fact, those n factorials will cancel out. 3 factorial into, now n minus 3 factorial can be written as n minus 3 times, without factorial, times n minus 2 factorial. Now this n minus 2 factorial will cancel out with this n minus 2 factorial. We'll be left with 2 factorial is 2 to be equal to 3 factorial is 6. 6 into n minus 3. N minus 3. So at this point, we have 2 to be equal to 6n minus 18. So what does this give us finally? So this will give us 20 to be equal to 6n. I just hope I've not left out something. And n should be equal to 20 on 6. I think there's an issue here. Is the issue coming from me or from the question?
From you, sir.
From me. All right, let me check it out again. N combination 2. So this is going to give us 2 into, of course, this will just be 2 on the left-hand side. On the right-hand side, 3 factorial is 6. And n minus 3, so 6 into n minus 3 into n minus 3. Of course, the numerators are just 1 because n factorial will cancel out on both sides. So I can write it like this. So from here, if I cross multiply, I'll have 6 into n minus 3, n minus 3 to be equal to 2. Equal to 2. So we can have 3n minus 9 to be equal to 1. Still have the same issue. And 3n is equal to 10. And n will be equal to 10 on 3. 10 on 3. So what did this give us? 3 point something.
0.1.
Okay, 3 point, okay, 3.13.
1.
It's 3 and 1 over 3, right? So it's 3.33. All right, so 3 and 1 on 3. So, however, I'm not sure we have the solution here. Okay, I see where I have made an error here. Exactly. Yeah, the fault is coming from me. Oh my gosh, I'm going to go away. Okay, at this point, n minus 2 factorial can be written as n minus 2 into n minus 3 factorial. This is what I left out. Please look at this. So this n minus 2 factorial can be written as n minus 2 into n minus 3. So we subtract 1. And then we are going to have what we have on this right-hand side. So this n minus 3 factorial cancel out this one. We'll be left with 2n minus 4 to be equal to 6. To be equal to 6. So 2n equals 10. And n equals 5. Yeah. Oh, sorry about this. Guys, are we together?
Yes, sir.
Oh, thank you so much. I'm really sorry about this. I'm not getting some post voices, so. Yes, I hope that some people have not put on their microphones to eat. Okay, they have not put it on to eat. All right, so this is the solution that we have. So n is equal to 5. Question 22. Any issues here? No. 22. Now, given that x squared minus 4x minus 1 is identical to x plus b squared plus c, the values of the constants b and c respectively are. So this is what we have here, and they want us to solve for b and c. So we can solve by equating coefficients. And from here, you will see that 2b is equal to minus 4, while b squared plus c is equal to minus 1. So if 2b is equal to minus 4, we see that b is equal to minus 2. So we can solve for b, which is minus 2 already, and then we get c as well. So we solve by equating coefficients. This is an identity. So 2b equals minus 4, b equals minus 2. And b squared plus c is equal to minus 1. B squared should be 4. So 4 plus c equals minus 1. And c should be equal to minus 5. So what is the key?
Yeah.
Yeah. So what's the key? Key C. This question. I wish that they were writing the GC as a group. We'll sit together and write like this now.
I tell you, madam.
This will be good. Let us propose this thing to the government.
It will be nice.
Yes, exactly.
Maybe don't accept.
Yeah, very
Maybe
good.
don't accept.
Yes. Okay, question 23. Two functions f and g are such that f of x equals ln x and g of x equals 9 minus x squared. What is the domain of the composite function? Oh. So let's first of all look for f of g of x. Our f of x is ln x, so I'm going to replace this x in f of x by g of x. So f of g of x will be equal to ln g of x. But g of x equals 9 minus x squared. So this is equal to ln 9 minus x squared. And how do we get the domain of this logarithmic function here? How do we get the domain of this logarithmic function here? Yes.
By look.
Okay, I'm not getting people talking again. So now this part here must be strictly greater than 0. So this must be strictly greater than 0. Because rule of 0 and any number that's negative is not defined. So 9 minus x squared should be strictly greater than 0. And if you factor this out, this is what we will have. We can use our number line to test. And you see that the region that will satisfy is between -3 and +3. Any questions here?
No, sir.
Okay, no. Question 24. What is this limit? How do we get this limit? How do you get this limit? Okay, we start by factorizing the denominator. Because if you just put 3, you are going to have 0 over 0, which is not making sense. So we have x over x minus 3 into x plus 1. When you factorize this denominator, you're going to have x minus 3 into x plus 1. At this point, we can now cancel out, and we'll be left with 1 over x plus 1, right?
Yes, sir.
And we apply the limit as x tends to 3, we'll have 1 over 3 plus 1, which is equal to 1/4. Okay. Now cos 2x over cos x minus sin x is equal to this one. This one like this, there is no formula. You wouldn't have to test each of the answers to see which one is the correct one. So this can be done by testing. And I decided to avoid any value that would give cos to be 0 or sin to be 0. So I took cos 45.
Sir,
Yes, please.
so sir, please, if you use the method, since cos 2x is equal to cos squared x minus sin squared x,
Yes.
and it can be expressed in like difference of two squares, which would be one bracket will contain sin x plus cos x times cos x minus sin x, and then now one of that will cancel with the other to give b as the answer.
Let us try this thing. So this gives us 2 cos squared x minus 1. Okay, no, not this. I understand now. So we are going to take cos x, cos squared x minus sin squared x, right?
Yes, sir.
Who is this person that just told me this thing like this? Please, let me get the name of the person that just gave me this.
Baby.
Bibi, this is excellent. Do you know that I've solved this thing many times and I've not used that idea? I've not even had the idea. I had to test. Oh my God, may God bless you abundantly.
Thank you, sir.
Yes, I know. This is why we always say that some teachers will come to class and tell you that the teacher knows everything. I always teach and say a humble teacher will always tell you the teacher does not know everything. The teacher learns every day. The day the teacher stops learning, the teacher should stop teaching. This is excellent. So happy. I wish that you were in class. I would have carried you up anyway, but that one can put somebody in trouble. It's good. Guys, you are not congratulating your, okay, it's their online mate. How do you call this one? I cannot call it classmate now.
Well
That
done,
was
no.
good.
Okay, I like this. Wow.
Well done.
You are saying in the Nigerian way, eh? Well done. Oh. This is how these Nigerians that we meet every day always tell us, well done. Oh. Okay, so this is cos X. And you see, the answer really comes out. This is really good. Oh my God. All right. You guys know, you send me a mobile money number, I'm going to send you 1K, their data. Guys, are you seeing how the answer is coming out?
Yes, madam.
Okay, you're saying now it's Madame. Eh? Okay. Know that when you're using the heavy voice to teach like that, you get hungry very fast now. So you have to make the voice soft. That's why you are thinking that it's Madame that is talking.
Oh, ish.
When you use bars, you lose a lot of energy when you're using bars. So make the voice sharp. You can teach for long. So that's the magic
okay.
that I'm using. Thank you so much. You're welcome. Okay, so this is the solution here. This is good.
Wow.
I think at the end of this class, I'm going to edit this particular place. Okay, I'm not going to cancel this one. Take the next step. All right. I'll give a screenshot of this. All right, the next question reads. That's question 26. Reads. Anyway, I had the answer, but I had to stress. Consider the answer is A, it's true, done by testing, but that's stressful. It's not really mature enough. Okay, now the coefficient of x squared in this binomial expansion is so the x squared term should normally be the third term, right? This expansion, our A is 2, our R, that's our rth term, should normally be 2 plus 1. Our B is minus 3x, our N is 5. So the power R is 2. So N combination R, 8 the power R, B is the power N minus R. So since the power of that term is 2, so we have 5 combination 2. 2 to the power 2 times minus 3 minus 3x to the power 5 minus 2. All right, x is missing here, but it's supposed to be here. Minus 3x, please take notes. But here, I've just left out the x because I'm interested only in the coefficient. That's why the x has been left out. So this gives us 5 times 4 times 3 on 2 times 3 factorial. This is combination. This is given as n factorial over n minus 2 times 2 factorial. So this one continues. So we can cancel out. Now times 2 to the power 2 times minus 3 to the power 3. And this gives us 10 times 4 times minus 27, which is equal to minus 1080. Or we can go the normal way by saying the first term is 2 to the power 5 plus the second term is 5 into 2 to the power 1 times minus 3x. And the third term is plus 5 into 4 times 2 to the power 2 times minus 3 to the power 2 minus 3 to the power 2, all this on 2 factorial. So this is the term in x squared. Also, I'll focus only with this term in x squared. This will give us 5 times 4, 20. 20 times 2 to the power 2 times 4 times 9 all these on 2. Let's give us the same solution. Okay, this is 2 to the power 4, 2 to the power 3. And let's see, this 8. So 2 here, 1. And 2 here, 4. 20 times 4 is 80. 80 times 9, what does this give us? We even have the same result.
So 180.
You have 180.
So you said 20 times 9, right? Let's play with other.
Yes, 20 times 9.
180.
180.
180. What's happening here? Let me just look at what I have here. Let me clear and read again. So this is 2 to the power 5 plus 5 into 2 to the power 4 into minus 3, all this on 1 factorial plus 5 times 4 times 2 to the power 3 times 3 squared, that's minus 3 squared. All this on 2 factorial. That's not what I'm going to have here. So we have 20 times 8 times 9 over 2. 2 here 1, 2 here 10. I know I'm having something else here. Let me see. The combinations give me the answer directly. Let me just check my work and see. If the second the R join R equals to 2, 5 combination 2. 2 to the power 2. 2 to the power 2 minus 3 to the power 5 minus 2. Those are 10 for 270. This, I think I'll just have to look at this one again. But this, my combinations here gives me the answer to be minus 1080, because the Tn term is equal to n combination R, A to the power R, B to the power n minus R. And if I put in all these my parameters, because I already know that R, the power of the term here is 2. If I fit in 2 here, that's why we are having this answer, minus 1080. And of course, that 720 is not even here. So working with this minus 1080. I'll check this one again. In case of anything, I'll leave an update in the group. Okay. Right. Let me just take a screenshot of this. 1, 2, 3D. Okay. Just a sec.
And there's no problem. I'm not even getting you.
All right, the next one. So 27, you have the integral from 0 to 2 of 2x on this. So how do we integrate this one? If we differentiate the denominator, what do we have? 4x.
4x.
So I can do some modifications to the numerator as follows. I've not changed anything, right? So I've replaced it with 4x and divide and multiplied by by a half. So that a half of this 4x will still give me back this 2x here. Is this okay?
Yes, sir.
So now the integral now will be a half ln of the absolute value of the denominator. This is supposed to be absolute value. But why have I not put absolute value? I've not put absolute value because all of this is going to be positive because the x is squared. So I have the right not to put the absolute value because this expression will always be positive. This one is ln, not LX, ln. All right, so this will now give us a half ln when x is equal to 2. 2 times 2 times 2, that's 8 plus 1, 9. So you have ln 9 minus ln 1, but ln 1 is 0. So this gives us a half ln 9, and which is the same as ln of 9 to the power a half. So that's equal to ln 3. If you bring this power back in front, we're going to have ln 9 to the power a half, which is the same as the square root of 9. That gives us ln 3. This one is okay, right?
Yes, sir.
Okay. Question 28. Two vectors A and B are given as A is equal to I plus 2j plus k, and B is equal to 3I plus j plus 2k. The vector product A cross B is equal to, how do we get the vector products?
So you use the matrix way.
All right, so you can use the matrix way. Are you talking about this one?
Yes, madam.
Yes, sir. That's what I'm talking
Okay.
about.
All right. So thank you, madam. Thank you, the madam again. So we have I, J, K. And for A, we have 1, 2, 1. And for B, we have 3, 1, 2. So this will be equal to the I components. You cover this row and this column where the I is. So we have 2 times 2 minus 1 times 1. All right.
4 minus 1.
Now for the J, so minus J now. The signs alternate. Minus J, we cover this row and column. 1 times 2 minus 3 times 1. That gives us 2 minus 3. And plus K now. Plus K, why minus K? Here's my pen. Plus K. So plus K into 1 times 1 minus 2 times 3. So this gives us plus K into 1 minus 6. So this is because of 3I plus J minus 5K, right?
Yes, sir.
Minus
Yes,
5K,
ma'am.
not plus.
Yes, sir.
Okay. Thank you, madam. So this one is supposed to be minus because of this sign here that yes, minus. Okay, you can move to the next question. Question 29. 29. So question 29 reads, the statement P is such that x squared equals 4, and the statement Q is such that x equals 2. So the only statement which is true below is let's see which of them is true. So P implies, let us look at P implies Q. So whenever we have x squared equals 4, it means that Q must be equal to 2. This is not true now because x can also be negative 2.
Yes, sir.
So this is not true. Then B, Q is implied by P. So whenever we have x equals 2, then it means that this one is equal to 4, but it's also partial because -2 is equally another one. Now C, this one is sufficient, though it's not necessary. Whenever Q is equal, x equal to 2, then x squared is equal to 4. And whenever we have x equals 4, then it means that x squared, 4 is equal to x squared. But this one is not also always true, because if we have -2 squared, it will give us 4. And if you have 4, it means that you can equally have -2 squared. But the last one is better. So because P is not necessarily implied by Q. So if Q is equal to 2, it does not mean that x squared must always be equal to 4. So because if x can be either be 2 or -2. So this last one is the correct one, because it does not necessarily mean. Now, this one they cross like this, it means it does not necessarily mean. And this holds because it's not necessarily mean, because x can either be 2 or -2. So we take the last one. This one is crazy. Okay, question 30. There are 6 black cards and 4 red cards on a table. In how many ways can 4 cards be selected from the table if the number of colors in the selection must be equal? In how many ways can 4 cards be selected from the table if the number of colors in the selection must be equal? So we must select 2 black and 4 red. So this one will be the probability, the combination of selecting 2 red cards from 4 red cards and 2 black cards from 6 black cards. So however, there is no order. So for the black, we have 6 combination 2. We are selecting 2 from 6, and then and multiplication. For the black, we are selecting 2 from 4. So since they said and, it's multiplication. So this one will give us 15 times 6, because 6 combination 2 is 15, and 4 combination 2 is 6. So this will give us 90 ways. Or you can bring the 10 cards and you check all the methods one by one. You have 90 ways to do it. Any questions here?
No, sir.
This year was a good year. Now, question 31. The equation of the asymptotes of this curve. Please, the class is going to end in less than 1 minute. When it ends, you log in again. Join again. Are we together?
Yes.
Yes, sir.
Yes, thank you. If it ends in less than 1 minute, you join again. So what are the equations of the asymptotes to this curve? So let's look at the asymptotes. The first one, the horizontal asymptote is y equals 0. And you can identify this because the degree of the numerator is less than that of the denominator. So when it's less than or equal to, we have a horizontal asymptote. When it's strictly less than, we have the horizontal asymptote equal to 0.